Hello everyone. So for today, I'm going to discuss the application of conservation of energy in real life. So before tayo mag-proceed sa examples, I prepared balikan muna natin kung ano yung law of conservation of energy. 'Di ba, sa previous discussion natin is ang law of conservation of energy, nag-state siya that energy can neither be created or destroyed. Again, energy can neither be created or destroyed. So, hindi siya pwedeng, yung energy, hindi siya pwedeng masira or hindi siya pwedeng gawin. So, kung ano yung energy input natin, yan yung total energy output pa rin natin. So, hindi siya pwedeng madagdagan or hindi siya pwedeng mabawasan. Okay. So, without further ado, let's have this. We have here our equation for conservation of energy. We have here E sub k plus E sub p is equal to E sub k prime plus E sub p prime. Some use this equation, or I mean the way they represent the equation, and others use this one. Ka final plus Pe final is equal to Ke initial plus Pe initial. So, itong prime natin dito, yan yung initial natin. So, initial yan. Then, ito naman dito, yung walang prime, yan yung final natin. So, nag-state dito na yung kinetic energy final plus our potential energy final is equal siya sa kinetic energy initial plus the potential energy initial na, nagawa natin in a certain situation. So, we have here again, let's recall ang formula sa ating kinetic energy. So, our kinetic energy na formula we have 1 half mv squared, on which yung m natin, that is the mass. Then, itong velocity naman natin, yung mass natin dapat naka-kilogram siya. Yung v natin, that is our speed. So, that is our speed, dapat naka-meter per second yung v natin. And also, we have here sa ating potential energy. 'Di ba sa potential energy natin, we have two basic forms of potential energy. We have here our gravitational potential energy and we have here our elastic potential energy. So, we have these two form. So, ano yung GPE natin? So, we have here our gravitational potential energy, that is mass times gravity and our height, that is mgh. Yung m natin is mass. Yung g natin, that is our gravity, and yung h natin, that is our height. Then, we have here our EPE naman. Sa EPE, we have here 1 half kx squared. So, as you can see, para lang siyang sa kinetic energy, but we have different letters to represent our units, or I mean our given. So, we have here our k. That is our, this is the constant. This is the constant of the spring, or we have here the spring constant. Then our x is the distance covered by the spring. So that can be ang pagka-compress niya or yung pagka-stretch ng spring natin. Okay? So let's get some example. We have here example number 1. So we have here a kid is sitting on a toboggan at the top of 23.7-meter tall hill. So if the kid and the toboggan have a mass of 38 kilogram, determine how fast they will be going when they reach the bottom of the hill. So let's identify first our given. So we have here, that is ito yung height natin. That is 23.7 meters. Then we have here the mass. We have here our mass, that is 38 kilograms. Okay. Then, that is only our given. Since meron tayong height na given, therefore, yung potential energy natin na gagamitin is yung gravitational potential energy. So, that will be mgh. Yan yung gagamitin natin for our potential energy na formula. Then, again, our kinetic energy, that is 1 half mv squared. Okay. No na yung dapat nating hanapin. How fast they will be going. So, yung hahanapin natin is yung speed natin when they reach the bottom of the hill. So, yung final speed yung kailangan nating hanapin. Bakit yung final speed? Kasi 'di ba, when they reach tapos na yung pagbababa nila. So, we have here, ano yung initial velocity natin? We have here our initial velocity. So, since from at the top of the hill sila nagsimula, so from the top of the hill, walang movement or wala silang ginawang action, that will be zero yung initial velocity niya. Okay? Then, um, then at the bottom of the hill, 'di ba? We have here at the bottom of the hill. So ano na yung ito yung initial height natin. At the bottom of the hill, ano na yung height, 'di ba? Na nasa bottom na tayo, therefore wala na tayong height. So yung height final natin, that will be 0 meters. So let's plug in this one to our formula. So again, ano yung equation natin? We have here KE final plus PE final is equal to KE initial plus PE initial. So, let's plug in our formulas, itong individual formula natin. So, we have here yung KE final natin. This is equivalent to 1 half MF final VF final V final squared plus, okay. Then, yung PE naman, yung PE final natin. So that will be, again ha, yung PE natin that is M, J, and H final. So sa initial naman natin, we have KE initial that will be 1 half M initial. Since hindi naman nag-change yung ano, yeah, hindi naman nag-change yung mass. So let's just erase this one. So then we have uh, our initial speed squared. So that will be our initial kinetic energy. Then we have here our GPE initial, that will be MJH initial. Okay, so let's plug in, let's substitute that one to this. So this will be, look, ito yung magiging itsura niya. That will be 1 half MV final squared plus yung final natin, that will be MJH final is equal to 1 half MV initial, okay, MV squared initial plus MJH initial. So, after this one, let's plug in. So, itong mga given natin, isubstitute na natin dito sa formula. So, copy natin yung 1 half. Ano yung mass natin? Our mass is 38 kilograms. So, 38, ay wait, yeah, 38 kilogram. 38 kilogram. And our final velocity, yan yung hinahanap natin. So, yung final velocity natin is unknown. So, that will be final velocity squared plus, again, copy yung mass, that is 38 kilogram. And our gravity, that is 9.8 meter per second. Then, we have here our height, meter per second squared, sorry. That is our height. We have here our height. That is our height final is 0. So, this will be 0 meter is equal to 1 half, ano yung mass, 38 kilogram. Then, initial velocity, that is 0. Since from rest siya, it will be 0 meter per second. Plus, we have here mass natin, mgh, initial. So, we have here 38 kilogram times our gravity, that is 9.8 meter per second squared times our initial height. So we have here 23.7 meter. Again ha, we have here 38 times 9.8 times 23.7. So since 0 na ito, so this will be equal to 0. So this is equal to 0. Ito din magiging equal to 0 since may 0 tayo dito. That will, the product of that now will be 0. So we have here 1 half 38 kilogram times our velocity final squared is equal to, ito, we have 38 kilogram times 9.8 meter per second squared times 23.7 meters. Okay, then, after that, we have here, divide natin ito by this one. This is 1 half divided by 1 half times 38 kilogram. So, this will be velocity final squared is equal to, okay, We can solve this one actually or pwede natin siyang i-plug in muna. 38 kilogram times 9.8 meter per second squared. Okay. Yeah. 9.8 meter per second squared times 23.7 meters all over. Okay. 1/2 times 38 kilogram. Okay, so ano yung magiging sagot natin? Let's have another paper. So let's have this one here. Continuation. So again we have here, let's copy this one. We have here V squared final, that is 38 kilogram times 9.8 meter per second squared times 23.7 meters all over 1/2 times 38 kilogram. Okay, so let's have this one. So let's use our calculator to solve our numerator and denominator. So we have here velocity final squared, that is 38 times 9.8 times 23.7. So this is, let's copy the whole answer. This is 8,825.88 kilogram times meter, that will be meter squared over second squared all over 1/2 ng 38, that is 19. So we have here divided by 19 kilogram. So velocity final squared is equal now. So divide natin ito. So that will be 8,825.88 divided by 19. So this is 464.52. Okay, ma-cancel out na itong kilogram kasi ma-divide na natin siya. It will be meter squared per second squared. After that, since may squared pa tayo, kailangan nating i-square root yung both sides. I-square root natin ito, then square root din natin dito. So this will be velocity final natin. That is equal to square root of 464.52. So let's have this. If we're going to approximate, the answer is, we have here this answer. 25, we have here 21.552722605. So if we're going to round it off to the nearest whole number, that will be 22 meter per second. So that will be the speed of the kid and the toboggan when they reach the bottom of the hill. Okay, so that's it. I hope you understand this problem. So this is just a problem for kinetic energy and involving kinetic energy and our gravitational potential energy na conservation of energy. So ito yung mangyayari on our given problem. Okay, so if wala nang question about this, I will upload another discussion for our elastic potential energy used in our conservation of energy. So I hope may na-learn kayo. If you have question, just comment on the comment section below. And if wala naman, again, thank you for watching. I hope you learned something. Bye-bye and God bless.